I've tried to get other people to get involved with Twitter, but yeah, it ended up being just me mostly for the 8 years. But I'm just disgusted with what's going on there at the moment, so I got off Twitter. And Toby has volunteered to take over our Twitter account. But the exciting thing is we've set up a Mastodon server. So Mastodon's kind of the open source alternative, and it's been growing pretty quick. We're getting about four or five new members a day. And yeah, you can all join. There's the URL there, mastodon.nycmesh.net. We're limiting it to only Mesh people at the moment. It might stay that way, because it's you get into moderation problems if you just let anyone join. So as long as it's just Mesh people, we should be fine. So I took a 2-week holiday this year. It was my longest holiday in a long time, and I went to Spain. And a big part of our inspiration for doing NYC Mesh was this network in Spain, Guifi. And we copied a lot of their things, especially the Commons license and the way they were doing wireless networking at the time. So while I was there, I visited Ramon Roca that started Guifi, and we were hanging out and chatting very intensely for one evening there about all the problems with networks and the history of Guifi and everything. They've got 37,750 nodes, which is almost exactly 30 times the size of ours. It's a pretty huge network. It's the second biggest. Like there's basically a monopoly, Telefonica there, and Guifi is the only alternative in the country. And the thing I didn't appreciate until much later was that Catalonia, is where Guifi is based, is fiercely independent and has a really long history of decentralized organizing, which is why they were able to do this. Like, you know, no one else has come close to what they do, and no one in this country until us had managed to do this kind of decentralized organizing that I'm aware of. There's a long history of failures of doing it in this country, and I think we're the first ones to succeed. So this is so he took me around the town. This is their first office. You can see their first wireless antenna on top of the building there. And I had a nice barbecue at his farm. Yeah, there's a farm there. And it's a big difference between Guifi and us is that we're purely city and then almost all rural. So they have an advantage where they can lay fiber in people's farmland because there's no one telling them not to. The farmers can just dig it up. They have the tools themselves to dig it up. And so they're mostly fiber now. And yeah, and almost entirely rural. Like I didn't notice much at all in Barcelona when I was there. That's the nearest city. But yeah, they're spread way out in all the farms in the countryside. And yeah, so we're one of the. He's very impressed that we could do this in a city. So we figured that out ourselves, how to do it in a city. That's Ramon and me after the barbecue and a few drinks. So yeah, there's this board election coming up, which everyone's excited about. And the board, really, we do the minimal amount of the board, and it's weird to see everyone excited about getting on the board, and because on the board we didn't make any decisions at all other than to approve spending. Like, we never blocked anything, because even to get to that stage it's been through so many filters and so much decision making that by the time a contract or whatever had appeared for the board, then you know it was okay. It's already been the decisions have already been made. So the board, I'd say 90% of what I've done on the board in the past, was it 3 or 4 years, is in the past 2 weeks of organizing the election. So that's, I think, what you can look forward to on the board is organizing the next election. So we have to have it because it's a legal requirement of a non-profit. You have to have a board and have to meet once a year, and they've got to make sure that we follow the bylaws of the organization. And to me, the main thing is, we make sure that the things we're doing are in keeping with our mission. And that's, to me, that's the limit of what the board should be doing. And that's just my opinion. That if other people get on the board, this could change. I hope not, but it could change. This is my personal list of worries about us growing. We're still growing really fast. And my biggest worry is that non-profits in this country are so dysfunctional, and and it's so easy to follow that path to become an organization that spends all of its money on administrative costs. Like there's one that spends 68% of their revenue on administrative costs. Like I want us to spend as much as possible on just doing installs and maintaining the network. Last year we got up to 17%, according to our bookkeeper here, and and about, I think the biggest chunk of that was bank expenses like Stripe and so it was mainly to do with banking. But yeah, I'd like to get that lower. So, and the other unusual thing for a non-profit, most non-profits are grant-driven. Most non-profits I know of, and we're basically self-funded. We've got grants, but that's not the reason we're still around. It's because we've figured out how to fund ourselves through individual donations. And like awful things can happen in non-profits where board members get paid huge salaries and stuff. Like, I don't get paid a cent from the Mesh, and that's the way it should stay. Like, board members should get nothing. and the board so far has agreed that that board members can't get paid, even if we have employees. And we should maintain this focus on installs and maintaining the network. And the other thing that happens in non-profits is the internal politics, weird power structures, and long lists of rules about what you do. And what I've found whenever you see a list of rules, it's because there was one bad actor and they had to make a list of rules to exclude that one bad actor. But yeah, I'd like to avoid all of that kind of horrible, degenerative non-profit things. We've got two revenue models now. The install payment page was our first breakthrough. We got down to, I think it was under $1,000 in our bank account at one stage. Like we were like weeks from going bankrupt. It was around that time we came up with a pay page with an opt-out donation button, and we made sure every install paid the install fee, and that way we weren't losing money on each install, and then we were getting the $20 subscriptions, so that saved us, and that page is basically why we still exist. And the other thing that's happened this year is Grand Street, where we are now, which is a HPD building. I'll talk about that on the next slide, but we did a contract with them and went through a lot of negotiations to get that right, and we get $10 a month from each apartment, and we got outside contractors to do a lot of the work, and we actually came in under on that, so we spent less than we bid.
I have a question. If a building, like, decides to sign on with Mesh and everything like that, is $10 a month per apartment in regards to internet?
Grand Street was completely different. It's the second model here. It's because it was a fiber install. And there's a lot. I could do a whole presentation about Grand Street.
And plus, they gave you the space too, which is a totally different scenario.
It's a very different thing here. But anyway, it was a huge success what we've done here, and we can copy this to other HPD buildings. It's actually easier now with the new regulations because HPD buildings have to supply internet. So an organization like us is perfect for them. And I speak to every week or two I get different HPD management company calling me up, asking about that. So we have these two models now, and the Grand Street one, we can just keep copying that amongst all these HPD buildings, which there's just thousands in the city. So I think that's our biggest chance for expansion. You probably heard of NYCHA, New York City Housing Association. We've done a huge amount of negotiations with them, and it's really slow. And the people that work there are really nice, and they're as frustrated as we are with the bureaucracy. But we will never get any money from NYCHA. They don't have money to pay us for anything. And yeah, and it's just ridiculously. It took us a year of negotiation for Vernon and 2 weeks to do the install. It's just a ridiculous amount of ratio of bureaucracy to.
HPD? What is HPD stand for?
Oh yeah, and the city has two organizations for affordable housing. It's HPD and NYCHA. HPD has gets independent management companies to look after the buildings, whereas NYCHA is centralized. And HPD works better than NYCHA as far as we're concerned. So HPD can pay for the installs, and they're quicker to deal with. The disadvantage is there's maybe 50 different management companies you have to deal with. So yeah, so that's there's a lot to be said about that. I might answer questions on that later. A lot of people wondering how to participate, and they think there's some hidden system of participating, whereas it's all out there. All you've got to do is join the install team. You can make presentations like this one. You've got to join our Slack. That's not optional. We just do everything on Slack. And if you've got a project, you can make your own channel in Slack and try and get people interested in your project. And if you want to do things you see that I'm doing, please tell me, and I desperately want to delegate some of the stuff I do. So there's no barrier to participating in anything other than getting people interested and building up trust. I'm doing way too much, and I really want to cut down what I'm doing. Like, I'm still doing installs. Like, after 8 years, I've done over 20 installs this year. I'm still doing lots of support, and these management calls with the building management take up a lot of my time. Project management, just general planning. I'm still organizing the meetups too. Jillian was doing that for a while, but I think she has health problems. Yeah, I was doing Twitter. I just stopped doing Twitter now, and I do bits of coding when things fall apart. So yeah, and the other question about how are decisions made, this comes up a bit, and to me it's obvious that it happens in Slack, but I think because it's so drawn out and there's so many channels that people think there's some other thing going on, but if you get in there and you can follow the history, these Slack discussions go back years of people trying to decide what to do and just eventually arriving on consensus. So like, there's some things, a lot of the hubs I've got no idea how they happened, other than that it's a channel for them. And I know that things went on in there. I like the Harlem hubs, which Rob has been doing. He's been doing an amazing job on organizing that. There's the Siklu point-to-point, which Daniel organized, and that went on for ages. We switched vendors on that because it didn't arrive, the things we ordered. But all of this is in the history in Slack if you want to see how the decision process went on. And with the Grand Street Guild, I had my first meeting here over 4 years ago, 2018. It took 3 years before we actually got the project going. And yeah, there's a really long history there you can delve into. And the other thing, the third thing here is that we have this culture which I wrote a thing in the docs about it. This is just a description of how I see us working, and it's not prescriptive, it's just the way it turned out. And yeah, we work on a system of trust. You get to know people, so then they get the passwords to different things, and we know they're not going to mess it up. And so yeah, you just get in there and chat with different people and show that, or learn how to do things. Like we'll teach you how to do different things, and you just gradually get to do more and get more involved. Yeah, because there's no structure, people think there might be an implicit hierarchy, and there isn't really. You'll see that I do more than most, but that's not out of choice. I'm just trying to fill in things that we need to do, and if I can get other people to do them, I will. The other bizarre thing is that most of us are softly spoken. It's this weird thing. Clayton from Silicon Harlem came to a presentation once and pointed it out, and I've noticed it ever since. Like, we don't really have people that yell and jump up and down that much. But, and the other thing is we try to avoid any unnecessary jargon and nerdiness. And we're very much into teaching people how to use technology. So that's all on the in the docs if you want to read that little bit I wrote on culture. Thank you. And next up will be Zach. Are you ready with your presentation?
Oh, yeah.
Yeah.
Check. Yeah. Thank you. Any questions for Brian?
Well, we can do questions after yours.
Excellent. After. Okay, no problem. All right. Oh no, it's in dual display mode. Okay, fine. Error.
I'm not seeing it.
Yeah, 1 second, Jolie. It's coming. I hope.
Can you take off that mic vision?
There you go. How's that?
Can you take off the mic vision?
Mic vision? Oh, night vision. Oh, yeah. You gotta have that. It's more fun. Okay. Did it work? Are you good? All right. So going counter to what Brian just said about no jargon, there will be a little bit of jargon in this presentation. So, okay, so the disclaimer on this presentation, I don't usually like disclaimers, but I thought it'd be kind of fun. You're not expected to understand all of this, but it could be interesting. So there is some jargon, but it is actually a medium high-level presentation. This stuff takes years to understand, and so this is kind of a presentation about what I've found over the last many years about this and what we can do with it at NYC Mesh. There's a lot of bugs in this code that I didn't write. So if you try to do this yourself, your mileage may vary. We might also want to have a technical breakout at some point, like a hackathon, to go deeper into this stuff, because it is actually really interesting if you're interested in it. But there's a lot more to it than what I'll show. And that said, even though there's tons of bugs in this code, the people who wrote this code are really awesome, and they're very helpful. So thumbs up to them. OK, so a bit of a history. NYC Mesh has gone over the last many years from being very small and having a first node up to 22 nodes. We built Supernode 1, Supernode 2, 3. We had COVID. And so here's just a timeline of some things that we've done in the past couple of years. The number of nodes, if you take the same kind of timeline and you put a very boring text below it, and you say, well, the number of nodes is sort of growing, it's sort of doubling every year, if you will, approximately. And we're somewhere around 1,200 right now, maybe 13, I don't know. Anyway, active nodes that are online routers, not necessarily people. And if you look just over some history, we have different types of history of how much bandwidth we've used to the internet. We've used somewhere around 70 to 100 megabits 5 years ago, and we're touching around 2.5 gigabits right now. We'll probably be over 3 by the end of the year. So we're actually growing quite a bit in our bandwidth. As well, an interesting thing is the number of open connections. So like if you open Google, that's maybe one connection, but Google actually opens like 5 pages within Google for images and stuff like that. So the number of active open connections simultaneously, kind of at a peak hour of the day in the mesh, is somewhere around 130,000 connections. So that's just various pages that are being opened and stuff that's being loaded. And that's kind of an interesting number for a moment. I'll tell you in a second, you'll see. So holding that in your mind, and then looking, what does NYC Mesh network look like? Well, we have all these hubs, we have these super nodes, and we have all these tiny little hubs and nodes that are in between. This is not to scale, no representative, but there's these big things, there's these small things, and they're kind of all tied together. So most of these lines are accurate. But there's this thing at the top, and that's the thing we're going to zoom into today. And we usually don't zoom into that very much, so that's kind of why we're going to look into that more. And well, what does it look like inside? Unfortunately, sadly, it's pretty basic. It's not really anything that interesting. It's a couple of computers hooked together, and then internet goes into it. Why? We haven't really needed more than that up to now, because we've really only had a couple supernodes. It's been sufficient. And really, there's only 2 computers in there that actually do anything. One is this Supernode 1 router A, which is about 18 years old. It's ready to go to college. And the other one, we should really put it away out of the house. And the next one is the Supernode 3 Edge 2, which is, it's fine, but it's not great. And so this does pretty much, like, if either of these go down, then we're kind of screwed. Like, we can do something to recover, but it's not great. And if you look at the internet connections we have that go into these, you could shake your hand about whether this is exactly correct or not. But we have 2 40 gigabit connections. We have a 10 gig coming very soon. We have another 1 gig. We have 3 to 4 upstream peers. We have about 3 to 4 upstream internet providers, including like NYC Board of Elections, which is really nice of them. And we have about 50 peers, nearly 100 gigabits of transit capability that we're not actually tapping into, right? And if we go into NYX, we'll pretty much double our peer count, which will be interesting later in the presentation as well. So some numbers. If you look at our public internet sources on the right here, this is the mix of, if you were to go to a website, through which provider would, who donates transit to Mesh, who would it go through? And we're fairly evenly mixed at the moment. This is just one view. This is Supernode 1. Other nodes would have a different mix. Other supernodes have a different mix. And normalizing that is kind of important in the future. But you can see it changes daily. The mix is continuously changing. So what drives our need for growth or change in this area? The number of connections. I said it's around 130,000. We can't do more than 65,000 connections per router. And so we're nearly at the top of what we can do in terms of number of open things simultaneously on the mesh. which hasn't bit us yet, but it will soon. We also need to move to a different type of NAT, which I'll talk about more later, but we're kind of restricted to a small number of IP addresses that people access the internet through, which is really silly because we have a lot of IP addresses. And spreading out this number of addresses will change the number of connections. It'll change the view that people have of the internet, the stability, and a bunch of other things. There's a lot of risk. As I mentioned, there's some poor quality or old hardware on our edge. The configurations are not really reproducible. Like, if you give me 4 hours, I could probably build a new one, but that means there's a giant outage for 4 hours, right? And somebody has to physically go there and do something with it. No redundancy as well. And then there's this interesting thing we'll touch on later about bandwidth management, where we have these cool internet connections, but we don't really do anything intelligent to select the path that your traffic goes in or out of. And then performance, of course. Right now, even if we wanted to use more transit, we are limited to about 4 to 5 gigabits total. Good thing we're only at 3 or 2, so we're fine for today, but by the end of next year, we probably won't be fine anymore. And there are some feeling of bottlenecks within the mesh, which are more accurate. So what's a good alternate for these edge routers? Well, we could go with like a giant Cisco or Juniper router, which is over $100,000. They're huge. They're closed source, obviously. They don't do everything. A lot of these are actually pretty good edge routers, and they could do 500 gigabits or more of traffic, but they can't, some of them can't do NAT, and some of them can't do NAT the way you want. So you would have to have another router next to it to do another thing, and so you end up piling up lots of equipment that doesn't really make a lot of sense. And again, it's real dollars that would be better spent on buying antennas and stuff like that, right? There's some projects like the BSD router project, which is kind of fun. For a couple $1,000s, we could build a BSD router that would do about 8 gigabits. It's not really pushing the envelope of what we can do. It doesn't get us much farther down the road. And there's a couple alternates to this, but these guys are pretty nice. And then there's the thing I'll talk about, the FDIO VPP DPDK, which we'll unpack that in a second. And for a little bit higher price, we could build a router that will do somewhere between 40 and 100 gigabits, depending on how we build it. And that's the thing I've been working on for a couple of years. So what is this VPP DPDK? It means it's a couple programs. One is called vector packet processing, which it processes packets in vectors, okay? Whatever that means. And then there's DPDK, which is this library written by Intel that basically communicates with the network cards and lets you do all of this. And so what is this combo? It's a program that directly communicates with the network card. It sits there and it's just an application that runs and it pulls for packets off of the card. So it's like reading them off the wire continuously, sort of. And it receives them in these large chunks of memory called vectors. And then it processes them in a graph like over here. So you say, well, okay, this is a packet. You remove the different pieces. We'll see a little bit of this later. And then you figure out what kind of a packet it is. And where it should go, you look it up, and then you send the packet there. Example features, you could do about 14 million packets per second per core. So that's kind of, in the ideal world, right? Millions of routes, thousands of routing contexts. You could do special NAT variants we'll talk about. VLAN gymnastics, so you can kind of like switch packets around in arbitrary ways. And it also includes crazy fast VPN endpoints, which is really something interesting for us. It's like a pain point sometimes in our mesh. But what about that $100,000 box? Well, VPP is actually donated technology to the open source world from Cisco. The ASR 9000 platform basically is VPP, and it is in these line cards. Each one of these is kind of a VPP engine. So basically, it's like the open source implementation, literally copying the thing that Cisco donated to the open source and being done by a lot of people. So we're done, right? That's like we're done, and everything works. We should just move on. Not quite. That was a great joke, right? Everyone laughed. Everyone laughed in the room for people on the mesh or on the internet. So in this project, VPP started around 2016. It worked, but only supported a few network cards, and it had a lot of problems. And then in 2018, which is when I started getting interested, there was a plugin called Tap Inject, which allowed you to basically use it as a router rather than just kind of arbitrarily mangling packets on the wire. So I spent about 6 months on and off on the mailing list trying to talk to contributors and trying to compile the thing. And by 2019, tap inject was broken. It no longer functioned with their mainline code, which was pretty sad. And then, this is a very well-known thing that this doesn't work anymore. And then they added CGNAT and they made it better, which is kind of something we really need. So that was great, but there wasn't any way to use it, which is unfortunate. And there wasn't really any changes in 2020. Sometimes VPP is used for Kubernetes if you have like a really giant Kubernetes system. So a lot of work was done in there. So the big problem is there's no nice way to control the routes that go into VPP. In 2021, there was still COVID. And this guy, was there still COVID? Or yeah, there was still COVID. And this guy, Pim van Pell, he's Swiss, began working on a project called the Linux Control Plane Next Generation, LCPNG. And this makes a connection between bird or FRR in Linux and the VPP routing table. So this is the missing component that everyone wanted to have. He runs a small ISP and he wanted to use this. And so his target was about 10 gigabits per second with this plugin still functioning. He released it in Q4 last year. It had a lot of bugs. I compiled it. It didn't work. There were a lot of problems with it, but for him, it worked for his use case, right? And then in the beginning of this year, it was rewritten sort of again. A lot of major bugs were fixed, which, when you start using it in production, you see there's a lot of bugs. He presented at NANOG, and it actually worked. It compiled, it works. However, this is a complicated project, so a lot of the other libraries didn't work at that time, so something was always missing, right? And so in the last few months, what I've done is I've started over, I changed to new hardware, I changed to new cards, new operating system, just everything from scratch, tried to build it the way they built it, and I got it working, right? So finally, this year, we can actually use it and it functions. Here's my test rig that I'm using. I have one server that's an Intel 20-core server with dual 100 gig Ethernets on it. And if you just loop those together, you can get 76 gigabits of traffic between card A and card B. Now, why 76 is limited by PCIe and memory bandwidth. So this is all that computer can do. I plugged it into a Juniper switch, exactly the same kind that we're going to use at SuperNode 10, with 40 gigabit. I put it into a VLAN, put it into a bond with 10 gig, put 10 gig over into the server, and then pin that to one socket in the server, which all the way through the route, through the switch, you can get full 40 gigabit. And then the part we're testing is all the way over to the right side, right? The reason that there's a lot of 10 gigs here instead of 40 gigs is because of all these problems with these different network cards. This is a card that works, right? So we need to do something there, and we have to figure out what to do about that to make it performant. What are the results? So there's results, and basically it will go full speed, right? So the iMix, there's a couple tests here. I'll talk about them. The first one's called iMix. This is a test that a lot of people have different opinions about. It's kind of a standard test, but it doesn't really do anything useful. It's just, let's do a mix of this size and that size and this size request. And it's a common thing people do, but it's not representative of anything. So you can do about 14 gigabits and 37 million packets per second with a 30 microsecond latency. So it's pretty good. DNS packets are interesting because if you ever have a DDoS, DNS is usually the thing that's used for DDoSing you, right? So if you have a denial of service attack. So the ratio of data in to data out is, data out to data in is 1.2 to 1. So you make a DNS request and you get back a packet that's very similarly sized, slightly smaller, and we could do about 18 gigabits. So we basically can handle an 18 gigabit DDoS attack with this infrastructure if we wanted to. The limit was actually, interestingly enough, the test box. The test box had 20 cores. I mean, the test server, the left-hand side, the Intel 20 core. So even though that server had 20 cores and the VPP server had only 8 cores, the VPP server was faster than the test box, right? So it's kind of interesting to see that it is very efficient.
Test box generates the traffic?
Yeah, the traffic generator, exactly, yeah. I probably should have worded that better, yeah. The other test, there's a data center mix, which is 3 out to 1 in, and then a web traffic mix, like if people were downloading streaming movies or whatever people do, looking at Twitter or whatever, or Mastodon, sorry. And then you can get about 37, 38 gigabits and about 5 to 10 million packets per second. So this is actually really good. If you look at it, our Supernode 3 router right now, the total end-to-end latency of Supernode 3 is about 1 millisecond. So this is way lower. There's a couple other, it might creep up a little bit depending how many things you have plugged in, but it is actually a big improvement. So we basically crossed off performance. We figured out the performance part of this puzzle. We crossed off risk because this is all new hardware. It would have to be new hardware. It just doesn't work with anything we have already, right? So the next thing we can concentrate on is the number of connections and the CGNAT problem. Well, VPP does CGNAT. Well, firstly, what is CGNAT? It's called carrier grade NAT, and it's a way for ISPs like T-Mobile does this and Spectrum does this, where they take your inside IP address, which is like on your cable modem, and they compress it into a limited port range on the outside. And so you can, for example, if you had this IP on your cable modem, this is like an example, somewhere in Spectrum they would have an IP like this, and you would go between these ports only, right, for your outbound traffic when you connect to somebody like Google or Twitter or whatever, right? It has a lot of, well, okay, so why bother even thinking about this? Yeah.
So that's different from regular NAT just in that you're using a specific range.
Yeah, it's different. He asked is it different from regular NAT because it's using a specific range? The answer is yes. Regular NAT, you basically choose an open port, a random open port. And so this is, it's more memory intensive because you have a table for every IP, but you also, it's easier to find the IP that's available, or I mean the port that's available. So it's a little bit more efficient, but largely it's used for things like the purpose of this is for law enforcement, which we're not interested in doing anything with that unless they ask us. Please don't. The idea is that you can look at this port and you can say who did a thing on that, and you can look back inside, right? Yeah. So we don't have that need, but
Switch the microphone.
yeah.
It's green. Green? Okay, I don't have it turned up. Now it's fine.
Okay.
Yes.
So then, yeah, how does this differ? Like, what's the benefit of this to us, right?
Yeah. In its pure form, the benefit would not be that great, right? What we do need to do is somehow find a way to distribute people over more than one address on the outside, right? And so what do we need to do, right? We need to distribute people through more than one IP, right? So we can get more than 65 connections, 65K connections. This is redundant. But if we do that now, the way we have it, if we were to just do that on our existing equipment, for any one connection you open, it might be on one IP or it might be on another IP. And so websites won't function properly. There's a lot of problems with that.
Right, you need to do the bookkeeping to keep track of which, yeah.
Exactly. You need to find a way to pin people to one address or another address. And up till now, there's a cool thing I'll talk about in a second, but up till now, you could either do the random thing, or you could restrict people to one IP, or you can make thousands of fancy rules that say, for that person, go here. For the second person, also go there. For the third person, also go here. For the fifth person, go there. And you can basically map it out manually. Or you can do something really creative and do CGNAT or something else. So that's kind of why we're going down this road. So the benefits of CGNAT, as I mentioned, there's faster mapping. It's application-based, so it's kind of threaded. You can spread users over many addresses, and it's kind of done in parallel because you don't depend on, people go through different streams of routers in order to, you can go through different streams to be able to do a CGNAT. But the big downsides is that because there's this port range for every user, you're restricted to no more than NAT connections, right? So if you have 100 tabs open on your browser, it's not going to work very well, right? And so this is a problem for people because they're going to probably do that, and it's not going to work, and they're going to complain, right? There's also less privacy because of the CGNAT is basically made for law enforcement, right? And another big issue is because you have this port range for everybody, you have to have however many people, however many nodes and IPs you have in the mesh times the number of ports, which means we have to have a huge chunk of addresses that are not well used. So this is not even really great for us. People complain about things like, my games didn't work, because of the port range problems and all this this is a common problem. It's also quite hard to find a good implementation, especially an open one. So an example of this, VPP can do CGNAT. So if you look on the left, you'll have a very number of nodes, and they'll kind of all map to their own little port range on every different IP address. But recently, as in a few months ago, there was a feature which isn't named, but it's called, I'm calling it for the purpose of today, sticky NAT, which lets you do regular NAT, but it hashes IPs over a fixed number of the internal IPs over a fixed number of external IPs. So basically, everyone can do 65K connections, but it limits you to only do it out of your assigned IP address. But you're not doing it manually. You can have as many internal IPs as you want. So this is what we need. This came out this year. So this is a thing that will really make a big difference for us. It solves the privacy concern. It solves the port limit. And there's no number of outside IPs that are required. So this basically, we're not doing CGNAT. We're doing fancy regular NAT, right? But VPP does this, right? So this is not something you can do with sort of a boring router. And somebody thought this was a good idea, and they committed the code, so it works. The last thing we need to really worry about, the problem we're trying to solve, is bandwidth management. And this is a complicated thing. People spend their entire careers trying to figure this out. But we have a much simpler version of this problem. It's just we have to do something about it, right? We can't just do nothing. We have to do something, right? And so, for example, the problem is if you have one router like we do at either of our super nodes right now, if internet 1 is much larger than internet 2, and you have 2 internet connections, right, the router will just flow out everything based on its best path, right? And so what you don't want to do is say, I want everything to go through internet 1 because it's faster. You want some things to go through internet 2 because you need to use it a little bit, but not everything. And so you have to figure out how to easily flow some traffic through one and some traffic through another. But if you have 2 routers, even at the same location, and let's say you want to do redundancy, you want to allow either router to die, and you put 2 of them and you plug each internet into each one, some odd things happen. One odd thing is that one side might go underused or not even used at all, depending on how your traffic arrives at the router, right? So some people may always be going out internet 2, some people may always be going out internet 1, and some people might go out internet 1 today, but might go out of internet 2 tomorrow, depending on how their traffic arrived at the supernode. It also will only exit, so if you arrive traffic at router 1, or the green one, or let's say router 2, which is labeled 1, the red one on the right side, I did a poor diagram here, then you might have no way to go out of router 1, right? And then there's another odd thing, which I saw many years ago, and it can happen today, is that if internet 2 has slightly more routes than internet 1, and it has different ways of getting to, let's say, Netflix than router 1 may always give the traffic to router 2, and then it exits. So it depends on the view of the internet. You may or may not go out of router 1 or 2. And so there's a lot of nuance and issues with this. And it's a huge pain if you have more than 2 connections even. So what we need is another layer of aggregation. And if you look at really large internet organizations, they have what are called aggregation routers, and they have edge routers. And part of the reason they do this is because they need to have a way to exit traffic through any internet connection they choose and make the selection somewhere else. And so we need to make an aggregation router as well. And we can do all of this function within the same, I think, VPP instance. And so this is not something that we have to buy a whole bunch of different chassis, a bunch of boxes for. We can do it kind of in one system. And that means that we can choose using good selection methods. Maybe one person goes to Netflix through internet 1, maybe somebody else goes to Netflix through internet 2, and we can distribute the load, various ways using, arbitrary selections like changes on the router rather than having to physically recable it or rather than using randomness, right? So it's kind of a cool thing. And then when you talk about the CGNAT and how it comes in, you know, what we do today is we just push everything through one direction and we NAT everything. But IPv6 and even public IPs don't get NATed. And so we have this complicated thing where there's different rules that say, if this address is like this, then do this. If it's like that, do the different thing. And instead what we can do is we can make this NAT system we talked about very dumb and redundant. And we could put it over in the corner, and then we just push traffic to it that gets NATed, and then it comes back into the main network and goes out. And so we can make a very normal way of doing this that is redundant, balanced, fast, and future-proof. Okay, so the next steps for this are we need to order some new Dell servers, which I've been talking to Jason about, and I'm a little bit behind in actually doing it. We need to order some new NICs, some new network cards. There's a little bit of an interesting thing here because I really wanted to get us to 100 gigabits, but those cards VPP is just such a pain with that. I think if we do 40 gigabits, we'll be good for many years, so which is kind of cool. The sticky NAT that I talked about, it works, but it's a little bit buggy, so it's another thing that has fun bugs in it that need to be worked out. And there's other challenges, like multiple routing tables. I mentioned these different things can be in the same VPP system. Right now, the control plane thing that Pim wrote does not work with multiple routing tables, so there's some other question marks there. And there was a question on the mailing list recently about whether you can do NAT and routing on the same instance or not. So these are tests. And then, of course, because I've mentioned a lot of this is kind of edgy, we need a backup router of some sort, right? So we need something that sits on the side that has a little tiny bit of traffic that can flow, like it can make the people in the mesh happy while the big one goes down because it broke for some reason, right? And lastly, you know, in the line of things breaking, like VPP is sort of stateless, and you can't really, it doesn't really save the configuration, so it's kind of scary. And so that same guy, Pim, is writing something that works with the configuration with a live VPP instance. So it's kind of interesting to, it's still fairly raw, right? So challenges aside, I think it's still worth it. This is a 10x capability for us, and I think even though it comes out slowly, I think it's worth it because we're not at the limit yet, but we should really we should look for the limit coming up. And so big thanks to Cisco, DPDK, FDIO, Intel, and the people, especially Pim, who did a really good job, and a couple of sponsors who donated some of this hardware that we're testing with. So pretty cool. Before questions, some bonus material. If any of you are interested, I mentioned that it's kind of polling, so I apologize if people don't understand all of this right here, but you can see that this 8.01 means that this process is using 8 CPUs of work, and it is basically just sitting there 100% CPU, like, do you have a packet, do you have a packet, do you have a packet, do you have a packet? And it's just doing it on all of the CPUs simultaneously. So it's kind of interesting. And actually, I can do a live thing here, but it's passing, you know, this is a bandwidth test in T-Rex application, so it's doing it. And we can go into this more if anyone's interested, but you can completely trace, there's that packet graph that I showed earlier, you can completely trace every packet that goes through and see, you know, like debug trace. I mean, what happened? Well, it came in this card, and then it looks like this, and then it went through the bond and went through the Ethernet, and it decodes all the things and makes a decision down here about what to do with the packet. So it's actually really interesting to dig into how it's going through and any kind of, you know, to see what happens there. So, yeah, thanks. Any questions? Yeah.
Yep. Can you hear me? So you were talking about redundancy, and I think that you know relates to uptime and failover and things like that. And then you also talked about running on the exact same piece of hardware at the same time for multiple components, right? So I guess I would see this as, first there's multiple supernodes, right? So exiting traffic from one or another, but let's just point at one supernode for now and not try to think of complicated things like connecting them into each other, right? So are you talking about now having two slices of physical hardware inside of there and both of them splitting that load? So if one fails over, who cares if it loses state and the other one just picks up from that point? And then if that one fails over, who cares because in the background you fix the other one and then that comes back, that type of a thing?
Yeah, sort of. So let's say if we go back here. So looking at supernode 10, for example, right now we only have one connection. We're about to have another. And across this one, we're probably going to have multiple upstreams. And we're probably going to move this one over there. So we're probably going to have, I think late 2023, we're going to have like 6 internet connections at supernode 10, right? So, or 6 upstreams, right? So we don't have to put them all onto one router. We can put 2 or 3 here and 4 or 5 there, or whatever. We can mix them up. And the ones that have more performance, we can put them onto a faster one. The ones that have lower performance, put them on an appropriately sized system, right? So what that would do is if one goes down, we can just use the other ones, as if there was an outage from the provider instead, right? So if we can do redundancy, if it's only thousands of dollars for us to do redundancy in there, because it is critical infrastructure, or it should be critical infrastructure, we might as well do it, right? And I think in a table, in a picture like this one, we can have multiple aggregation routers that actually load balance, and we can have multiple switches that are, parallel, right? NAT engines are sort of, I'll put a big star here, they're sort of stateless, so we can kind of be okay with that and have multiple of them, right? And then these routers are just, it's only for that path. So if you lose any one of these things, there's another one that does the same thing. So it'd be nice, if we can achieve this, that'd be great, right? If you only have one connection, with the way things are today and with the way all of our providers are, for example, we don't get 2 connections from them. It's not like a critical thing for them to do, right? So we can't plug it into 2 routers. It's going to be one or the other. And we can do heroic things to make it happen, but it might not be worth it, right? Yeah.
And so then this probably steps a little bit out of the content of the presentation, but as you exit that space and you go into distribution networks, right? So I don't know if that's like redundant in any capacity at all whatsoever, or if there's just like sectors that are only the sectors, right? So we might have this great redundant infrastructure that's, inside our peering exchange, but then not our transition layer as it gets outside.
Yeah. Doing it with no context about why we're doing it would be dumb, right? But for example, supernode 3 has, 7 or 8 antennas off of it. So, they're not redundant, but they go into this web of the mesh, right? And so most of our supernodes, except for supernode 10, which is brand new, have 3 to 8 antennas, right? And so even if we lose one, well, the traffic will flow back here and then back out. The important thing is that these things are designed to fail, and we're building them purposefully in a giant web, and we're not doing that with our supernodes right now. And we should, so that stuff down there, which is well constructed in terms of redundancy, if you will, let's just assume it is for now, that's an opinion, then, if the supernode goes down, then none of that matters, right? It doesn't function anymore, yeah.
So now speaking a little more to the rules inside of it for determining exit traffic, right? So like at my place, I have dual WAN, right? And I spend a little bit of time picking out going one way or another. Yeah. Every once in a while when I leave the house and it says, oh, I put a lot of stuff over into Spectrum right now. Let's put some stuff into Mesh. Yeah. All of my things on my Apple TV are very upset, right? I have to exit every application. I have to reopen them because like it tries to keep those active sockets going to a spot that it doesn't have a route against. Yeah. So, what's that? You took what? Oh, you have the same setup? Yeah, the same setup. Yeah. So all of us are terrible at doing this. Yeah, so how are you better at doing this?
Yeah, so this is different because we're using, when we talk about internet connections, I'm assuming that there's BGP between all of these. And so there's an IP address space that's shared among all of this. And let's say, for example, let's do something really trivial. NAT engine 1 in the back here might have like our 208 address space. And that engine in the front might have a 23 dot address space. These are public addresses. And so we might lose one, but, or Yeah, I mean, if we lose a connection, there's different things that will fail different ways, right? So your example of the internet failing or switching from mesh to spectrum, that would be the equivalent of losing one of these routers or one of these upstreams. That doesn't make any difference to us. Your path to internet is changing all the time when you're at one of these edge nodes like this. And so you would see no difference. You know, I've done this live on SuperNode 1, and we shift people's traffic a different direction, and you'll never know, right? What you might notice is if we lose an entire NAT engine, you might notice it for a moment, but this is like a hard failure that is recoverable, right? These other ones are soft failures that are transient. You won't notice them, right? They'll just occur, and then sometime later it'll come back. This is normal. So the idea is put as much as you can into normal transient things that don't make any difference to anybody. The path changed. Traffic is still flowing, no one notices, and then you shouldn't have any problems. So this accounts for that, is what I'm saying.
Can you speak a little bit more into the VPN? So you talked about how that's like, it's much better, right? It's super good VPN or something. What was your descriptive word inside of it?
Yeah, so I mean, VPP is this C++ application, and these different nodes are, you know, encapsulating and decapsulating. So if you look here, this is like coming in from the PCI. This is basically removing the bonded interface. This is removing the Ethernet pack frame. It's removing the IPv4 frame, right? And so what you can do is people make a VPN decapsulator node. And so somebody's made one for IPsec, someone's made one for WireGuard, someone's made one for a whole bunch of different things, GRE, for example. And so the super good part of it is that because it's not running in the kernel, and because it's not going through Linux, it's going through the application, it's just treated as a node in this graph. So basically, it would have similar performance to all the other things. Like it can be parallel, multi-core, you know, as fast as you can go, right? So people are seeing, like there was an article recently, someone did, was it 800 gigabits of IPsec encrypted traffic between two VPP instances? It's like insane, or 600, I think it was. It was an example set up at, I think, Cisco, and like it just does it, right? So it's not a different VPN, it's not something new, it's just the fact that they go through this pattern allows you to decrypt packets, you know, in this very fast way. Yeah.
Okay, yeah, I guess I was asking because there is, like with expansion, right, where we don't have, you know, we can run fiber, we can do these microwave links or whatever, right? But like eventually, it seems like Harlem expansion, that's a VPN thing, right?
Yeah.
And there's like, I forget the new name of the spot that's,
Yeah.
but there's another VPN spot that's an exit from that. So I assume more traffic will show up at supernodes that are exiting through that location, right?
Exactly, and so that's one reason why it's worth calling out is that our VPNs right now that suffer a little bit. I mean, if we don't have to do a VPN, we shouldn't, right? But if we do a VPN, we can begin to move to this style, and those existing technologies should be improvable, right?
Back to your high-level block diagram network architecture at the beginning, there was the link between the supernodes for the connectivity that went over the top.
Yep.
Is that intended to be a VPN link between the two? Or what is that?
Yeah, these are actually VPNs right now.
Okay,
Yeah.
cool. That's what I figured.
And we, you know, part of the unwinding of the legacy pieces is today we have to have those. In theory, we don't have to because we actually have paths between all of our supernodes across the mesh. But because we only have one router on the outside, and because it does NAT, and because of the way we do our transit, today we do need to have these in order to exit the traffic successfully. Like if you have a supernode 1 IP that shows up at supernode 3, we have to somehow transport it back to supernode 1 to exit, right? And there's some funny reasons why.
And that also gets to external static IPs that are assigned, right, too? Like
Yeah,
if
for
each
example,
provider independently has a specific subset of them, if you showed up over here, that wouldn't work for you, right? If
Yeah,
one of
yeah,
them done.
basically it's prefix ACLs on the upstream BGP providers, yeah.
Cool, thanks.
Anything else? Yeah, hold on, Jason's got it for now.
Yeah, question. Where are the bottlenecks in the network now? And will this significantly change that?
Yeah, so different supernodes have different bottlenecks. At supernode 10 from Grand Street right now, the bottleneck is the VPN. So this will fix that quite a bit. At Supernode 3, the bottleneck right now is probably the antennas in, but very shortly after that is the router out, right? At Supernode 1, the bottleneck is definitely the router. That's been a bottleneck for a long time. And then Supernode 1, the next bottleneck is actually the upstream connection. It's only 1 gigabit. So the bottleneck is not always the router. Some people may not see a major improvement on this, but at peak times they will. And under certain conditions, like periodically we have a large number of those connections open at 130,000. And routers, like the Supernode 10 router, for example, will struggle heavily under a large number of open connections, right? The VPP doesn't. In these other scenarios I was testing, I had 100 million flows of DNS. So it's basically like 100 million computers DDoS attacking you simultaneously, and it's fine because it doesn't care about one packet to the next. It just turns the crank on them, right? So to answer your question, back to your question, I think some of them are antennas, but as we build more antennas that are like the Ciclo antenna and so on, we're going to be getting 10 gig to the node. We may not have 10 gig coming from any one building, but in aggregate, it's going to start to build up. Right. I don't know, Daniel, what do you think about number of the bottleneck at like Supernode 3? Sorry to pull you at the second.
Can you repeat that question?
Like the Supernode 3, you know, what do we have, like 7 or 8 antennas there? Do you think our biggest bottleneck is the antennas, or?
I think the biggest bottleneck is the antennas and a space issue. Like in terms of like the expansion that we want to do there, it's going to be, you know, especially if there's more development in Sunset Park and in downtown Brooklyn, there might be a need to rethink how some of the antennas are laid out, especially with the new technologies coming along. And also and personally, I think it's our interconnect with the switch to the router. Like we're almost out of ports there, and we're actually at Vernon as well, so it means that there's a little bit less opportunity to play around in high traffic areas. And I actually did want to ask a question about like how, you know, right now, the core, quote unquote, of as opposed to the edge at Supernode 3, there are 2 virtual machines on 1 box. Do we plan to change that so then we'll be able to we'll be able to more piecemeal operate these things and also allow, let's say the edge does go down or we do need to maintain the edge, still have Supernode 3 antennas reroute to various parts as well?
Yeah, that was kind of the point of this presentation, is that the recommendation here is to build a new infrastructure that is redundant and fast. Yeah, and if we look at like the last slides, you know, this was his question. I'm blanking. Sorry. Yeah, high tech. Yeah, exactly. I was going to say I don't remember his real name. High tech. Yeah. He asked like, you know, what things are redundant here, and like, you know, as you transition one internet connection to the other, this is seamless, right? If we lose a router, this is seamless. If we lose a switch, it's seamless. If we lose one of these things, it's seamless. Losing one of these is a small blip, right? But the rest of it is quite seamless. And so we can, yeah, I mean, that's a big improvement. Is what we're doing there now is not good. It's just, that's why to do this, right? Yeah, that's the point.
And in terms of like addressing switch things, I'm trying to think about, because I've been thinking about that particular issue on like how do we build capacity on the roof so then we are able to have adequate bandwidth from our rooftop switch to, you know, to downstairs.
Yeah.
I believe we are, you know, we only have 1 connect, but the fiber contains multiple fibers, right?
We have 20 gigabits to the roof. So it should be enough for now. It's 10x what we can do there today.
No, like physical ports. Like
so that's a different, you know, I mean, that's a very good concern. It's definitely something that we should work on. I mean, but that's a different scope, right? That scope is like, well, there's physical limitations like number of ports, amount of antenna space, amount of power, right? Or downstairs plugs that you plug it into, right? So like those are like physical limitations, right? This is more of a logical limitation, right? Or, I mean, when you have the servers, you need to physically do them so they're redundant, but if they're running the boring stuff, then they're still gonna be slow. So we need to do like a fancy thing and have like this architected sort of like this so that we can flow the traffic efficiently, right? But you're absolutely correct; those are also issues. Yeah.
And since we only have one connect at Supernode 3 for, like, that goes to pilot,
Yep.
would that mean that we have to incur downtime in that switchover if we're literally switching over our uplink from our, from our virtual machine box over to the new Linux, to the new VPP box?
Yeah, probably there will be downtime. I mean, we can find ways to avoid it by VPNing with a third box back to somewhere else, right? So I think that this is not, I'm not suggesting we do a naive thing and just like rip it out and like, now what are we gonna do, right? Like this has to be planned. But yeah, there probably will be various downtimes across the mesh as we do this. But this is a year-long effort where you put the stuff in, the aggregation routers are available on the network. Probably somewhere in here, the old stuff will tap in, right? And then you can put the new thing, and then you can move one of them over, right? In the case of Supernode 3, there's only one thing to move, right? So it'd be 3-minute outage, and we could go there at 4 a.m. to do it or whatever, right? But yeah, certainly things like that. Yeah, those are valid concerns for sure. We got a question in the front here.
Yeah.
Do you want to have the mic so that people can?
In regards to the upgrade. Oh, thanks. And, hey, what's up? It's Keith. Africh's Human Active Score is the nonprofit that I'm representing. In regards to the upgrade, how much, like, it sounds like it's a software upgrade, but like, am I wrong? There's like, how many pieces of hardware are you talking about? Like, you're talking about like a router, an engine, and an aggregated router, but like, it sounds like 3 different things, but like, how many actual pieces would you need in terms of like the network? You're mentioning like Supernode 1, 10, and 3. Like, how many of those are actually going to receive the hardware?
Yeah.
And how many pieces of hardware is that?
Yeah, so this is definitely not a software upgrade. This is a new complete stack of stuff, right? From switches and wires and servers all the way up to the software, which is kind of the earlier part of the presentation. So, for example, I'm still working this out, but for example, these aggregation routers could actually be, and there's actually a positive synergy of having it on top of these routers. So it might be a virtual plane within that same box. And the reason is if you have traffic going in, you can just move it from one memory location to another rather than having to go back to a wire, right? So we might only have 4 things that appear on here, but
are those like 4 pieces going to be like 4 additional pieces to each one of the supernodes?
Yeah.
So it's like it'd be like 12 different things then, like, or
yeah, sure. Yeah.
Okay, all right. That's like I want to ask that in regards to that because I'm interested in building like a supernode or hub. I'm not quite sure what the difference is other than like one sounds a lot larger as super or whatever like that. But I would like to have a hub in Little Caribbean and whatnot in order for there to be ethnic and also gender parity in regards to people that have access to high-speed internet are able to learn about digital stewardship. And if this is gonna like the numbers that I've been running in terms of the budget has been like based on like how much Saratoga costs, like how big of a difference in the cost would that be in regards to this upgrade? And are you guys like doing this upgrade to all the nodes in which you are building moving forward, or are you requesting your partners to like come up with like an extra 2 stacks or something like that?
Yeah, so we don't actually have any partners. We're just nonprofit on our own. But I mean we have. So when all the donations come in, right, from various nodes, there's money available for the organization to spend on benefiting the community, right? And because everyone pays a little bit, and so a few dollars from everyone's pocket from the donations should go to improving our core infrastructure, right, which serves them. So this stuff doesn't really need to be like, we don't need to go ask anyone for money or like look for a grant or something. This is just something that is like kind of routine maintenance,
right.
But in a really good, like it's an upgrade routine maintenance, sort of upgrade/routine. And so hold on a second. With regards to the hub that you want to build and everything, your hub would be one of these kind of hubs that's out here. All of this stuff that I was talking about is only in this top layer. And this layer, I didn't draw it here, but any of the donated internet connections that we get come into one of these. The donated internet connections don't actually go to a hub directly. They go to one of these, and the reason is because the stuff in the field, the stuff like on Saratoga rooftop and everything, this is subject to like extreme cold, extreme heat, it's very low power, it's got to run antennas, and so, and it does like a different kind of routing than what you do to actually take the traffic onto the internet. So this kind of stuff that I'm talking about is not for, like it benefits hubs because the hubs are downstream, but it doesn't actually get implemented in a hub. Does that make sense? Like it's sort of part of the backbone infrastructure of the whole organization.
And also, I also wanted to ask a question. Like, am I correct? Like, when I went online and looked at like the bill of materials in regards to like Supernode 1 and also Saratoga, like the amount that it costs is somewhere like around like 3K or something like that.
Yeah.
Like, I'm not wrong in regards to that, right? Like, there's no surprise cost or something like that, because I'm going off the bill of materials that I'm presenting to like the grantors.
Yeah,
with that.
You should
bill of
work
materials.
with one of like our install volunteers to kind of like build out a list of what you want to do, because that's like different than this, right? But I mean, it can be more or less depending on your building, right? Like, what do you put on there? It's not stuff that like, oh, you know, we got to stuff some in our pocket, like the overhead, like Brian was talking about. It's more like whatever whatever it actually costs, right? So like if you have 4 walls and your walls are like extra high, maybe there's more poles required to go higher. Maybe you got to have more bolts or less bolts, you know, to put the antennas up. Maybe your distance from something else is too high or too low, and so you might use a fancy antenna or a cheap antenna. Like all of this stuff is what factors it in. So like your location and where you're going to connect to, and that kind of stuff is what drives the cost, pretty much. I mean, that's all that drives the cost. How many things you want to serve? Like, are you going to serve all the apartments downstairs? Like what is at the node is like the cost. But yeah, generally it's like several $1,000s, right?
Question to you to engage this is like, are you trying to be a component part of NYC Mesh, or are you trying to be a parallel competitor to NYC Mesh that's totally owned just by you?
Both of those are okay, by the way.
Yeah, like it's not a bad
I'm
question.
saying that will scope if you want to be a supernode or if you want to be a hub. And a hub is much less complicated.
It's looking like possibly a supernode because non-zero sum. Like I do want to contribute to like the overall accessibility of the internet, as well as you know, the ethnic and gender parity lens is of utmost importance in regards to me as well in the long term, because you know, there's a lot of like untapped human capital globally that hasn't been considered for so long that rather be on the upcrest and like, you know, in regards to it.
Yeah, I mean, you know, you're welcome to be part of NYC Mesh, and I think that building a hub is a really great way to do that, especially if you're in a neighborhood that's already served by NYC Mesh. And, you know, but, you know, one of these supernodes, these terms are kind of silly, right, in terms of supernode or hub or whatever. Like, they don't mean anything, right? It's just the supernodes happen to have like an internet connection that was donated over fiber, and then like they're in a data center somewhere.
Oh, that's
right?
another thing that I want to ask as well too.
And so like these like if you wanted to build a new supernode in the middle of nowhere, like in somewhere in Brooklyn, right?
It's not so much in the middle of nowhere. It's in between two colleges.
I mean like in some building, right? Some random building, right? If you want to do that, like that's a whole fresh experience, right? That's a different experience than building a hub, because there's like different things you got to bring in, and you got to have racks of equipment and that kind of stuff. And so NYC Mesh, like we already do that as part of the community as a whole, right? We have these locations, right now 3 locations, that are like in the data center, and they have connectivity that's donated, it's fiber based.
Majority in Manhattan, right?
Supernode 3 is in Brooklyn, these are in Manhattan, but it doesn't matter where they are because the mesh map, like these are just part of the mesh, right? So they're on the map somewhere, and like you don't have to be close to it. You can be somewhere far away, and like it all transits over. Yeah, we can pull the map up.
Yeah,
if you want.
I've seen that map.
This is primarily Brooklyn, actually, a tiny bit in Manhattan, but it doesn't matter where the you know.
If you don't want,
I think Jason had a question.
Which one of us?
I think you.
Oh, okay.
You might ask a question.
We're sitting around here.
Yeah, like from here all the way
with the
down.
mic, you're saying.
Oh yeah, with the.
You had seen the mic, yeah, thank you. So Zach, question. So I think you said with 1,300 members that we currently have, and we're going to be scraping the ceiling around, what did you say, 4 gigabits?
Yeah, on our existing infrastructure, we'll scroll down here for a sec. Let me put this back up. This stuff right here is Supernode 1. It can only do about 600 megabits. And we've offloaded a lot of that because a lot of the Brooklyn things are now successfully going through Supernode 3 with new antennas we have, right? And Supernode 3, so this is like, we're only hovering at about 400 megabits per second at Supernode 1, so we're below our threshold. But this one is definitely bottlenecked pretty much any time, right? It can be. And then over here in Brooklyn, the limit is kind of between 3 and 5 gigabits, depending on how many connections there are, right? And so, you know, if we look at like,
So
yeah.
as far as the whole network,
Yeah.
at 1,300 members, we're scraping the ceiling in a few places,
Yeah.
and at least a couple of our supernodes.
Yeah.
With this improvement, what will it allow our membership to grow to?
Yeah, it's a good question, Jason. Yeah, thank you. Yeah, that's actually a really smart thing to ask. And the reason is that, you know, we probably need about 1 megabit on average, right? This is not how much is served to a person, but on average, in aggregate, you need about 1 megabit per person on the mesh, right? So we think, I like to guess that we have about 3,000 people using the mesh. That might be wildly inaccurate. Maybe it's 2,000, but we're using between 2 and 3 gigabits of traffic. So it's kind of about 1 megabit. So if we do this and we successfully get up to 30-something gigabits, we'll be able to handle up to 60,000 people, right? And then at peak, yeah. And then the number of IPs as well, like the 130,000 connections per second, we're kind of stuck at, you know, how many people open how many things. Okay, well, at a couple thousand, we're limited to, you know, 100,000 connections per 2,000 people, right? So we can't really handle. We're soon going to be on that bottleneck, right? So I think going to 512 IPs times 64K means that we can handle over 100,000 people on the mesh, right?
And at our growth rate, it may be doubling per year. That's looking like 5 or 6 years.
Yeah, sure. Yeah, which is why, you know, if you look at like this, you know, we say, you know, we've been, yeah, exactly. We've been up to this point here. Let's say that, you know, we hit 6, 12, 20. You know, I don't know that we're going to grow linearly, but we can plan for it. Yeah, in 3 to 5 years, we're looking at this equipment being
Necessary.
well, not necessary, but already overloaded, right? Because now it's necessary, or by the end of next year, it's necessary. And then once we do this upgrade, let's say we get through to, where was the slide here? I'm sorry for jumping around. If we, I don't know where I put it. Anyway, I mentioned somewhere in here that this is not the fastest we can go. We can go a lot faster. But because there's so many bugs and complications, if we just buy the boring thing for $500 each, you know, the cards and stuff like that, we'll be good for 5 years, right? And then we can do another upgrade in 5 years, which I think would be very reasonable, right? I don't think that anyone would argue that every 5 years we can replace some of the equipment, right? Yeah.
Right, great, thanks.
Yeah, sure. I think Leiden has one next to you.
I'm also kind of one of the things that you pointed out in terms of the whatever something NAT, I forget what,
Yeah,
CGNAT.
CGNAT, yeah.
And how that works is I'm not sure exactly how many IP addresses we have that are exiting traffic total of the mesh.
Yeah.
But that is one thing that we should be looking at, because I know we've had issues before with, where websites will have problems when you have too many people exiting from one IP address, and that's something that we kind of have to.
This addresses that problem.
Yeah.
Right?
I'm saying that this would be a solution to that problem where
Exactly.
we can split up some people so we're not funneling the entire mesh
Exactly.
through three
and if we
IPs.
had, if we got 10x in size, if we achieved that, then that problem that you mentioned happens every 6 months or so for a day or so, right?
Yeah.
Randomly guessing, right? Just people might feel more or less than that, right?
Yeah.
But if you have 10x people, like how often does that happen, right? So we can't exit the mesh with what we have. I mean, we can't exit the future mesh with what we have. We have to do something, right? So this addresses that, yeah. And to how many addresses we have available, between 500 and 1,000, depending on how we chop them up.
Okay.
Would be, so we can handle, I don't know, let's do some dumb math. We can say like, I know we have about four 256 aggregate, 256 IP prefixes, that's 1,024. But they're not all available for complete use, and they have to be kind of chopped up in different ways. So let's say we did 512 times 65K, right? We're looking at 33 million open connections we can have, right? And so that would address, I don't know if it's like 1,000 connections per person, 30,000 people, right? 1,000 per person is kind of absurd, especially because, it's just kind of absurd because not everyone's always using their full, they don't always have 100 tabs open, right?
Yeah.
So we can handle, between 30 and 80,000 people on that system, right? So that's kind of, I think that's a good target for us to address, which means that in the meantime, everyone will have a very enjoyable experience, and as we grow, we can monitor the responsiveness and figure out when to upgrade next, right? Which is not something we've done prior to now, right? Yeah. High Tech has a question.
So we've got all of this wonderful edge routing, right, that we're talking about, but we're still using OSPF for how everyone reaches it in the first place. And it sounds like Supernode 3, which is Brooklyn, which has 1 gig and probably could live
No,
with...
it has 40.
Oh, is it 40? Okay. So was that the one that only had a single exit and wasn't redundancy?
Yeah, single exit, 40 gig, no redundancy, yeah.
Okay. So I'm just thinking like the volume of users, right?
Mm-hmm.
And like, how would we make that traffic steer towards Manhattan instead?
Yeah. So I don't think that it's wrong for us to use OSPF. This doesn't add or remove any performance implication. Doesn't have any performance implication, right? It's just like if we did something else, it might be quite a bit more complicated. So I think we're good with that for a couple of years. We may have to do some really fancy things if that's not good enough, right? But pretending that it's good enough for now, I mean I don't want to put that aside. That is actually like whether or not we continue to use OSPF is a big question, but it's a completely different world to think about, right? But about say exiting traffic from Supernode 3 if it goes down back to Supernode 1, right? There's a number of things we can address that are not currently worth us doing in terms of dollars, but in a few years it might be worth it. For example, we could have a fiber connection between Supernode 3 and Supernode 1. So we could do our own redundancy. If we have 6 connections to Supernode, 10. If we have 6 connections at one of the Supernodes in Manhattan and only 1 in Brooklyn, we can run a fiber between them and we can lease a fiber between them and we can say, okay, exit either way and be more redundant that way. That's one option. We can also buy more internet at Supernode 3. We may need to buy internet not because we're out of capacity, but because we want additional redundancy. And that's a $1,000 a month question, but $1,000 a month may not be out of the question in a few years if our growth is a good growth, right? So I think we can address those because those are like solvable problems as long as you have the right infrastructure, right? But maybe we don't solve them today. Like they're probably not the highest priority, but it is actually a real concern, but in a few years, I think. Does that make sense? Does that help?
Yeah. I guess my root of the question is like doing hardware level upgrades, right? Is there even validity in doing that in a place that doesn't have the capacity for redundancy? Yeah. And are we just going to change OSPF costing to like send more things towards exits in Manhattan purposefully because of that?
Well, so it's not just about redundancy. I mean, it's about like let's say you didn't have this thing, the second, like let's say you didn't have any second one of any of these things. It still moves us from 3 to 5 gigabits per second capability up to 40, right? 30 to 40, and we have 40 gigabits there, right? So right now we're underusing our single available connection, right? So the one that we have that's not redundant, like we can't even use the whole thing. So it's worth it doing it still. And then with this infrastructure, you can just add another piece on the side, right? So there's value in having single redundancy or even just straight upgrade, right? This is just, if you look at our Supernode 3 router, single power supply, it's been on for a couple of years straight, less than Supernode 1, but it's been online for a long time. one network card, one fiber, two hard drives. Like, it's really, I'm surprised it hasn't broke yet.
Yeah, really lucky so far.
Yes, yes, exactly. So I would suggest that that's the reason we should do it, even if there's no redundancy. When you get the redundancy, what you do is you just plug in the second connection to the second thing, so that transaction should be searching for internet, not searching for like a re-architecture or architecture. Yeah.
I have a question.
Yeah, jolly. Use the mic.
I have a mic.
Okay.
Why can't Supernode 1 be upgraded, or can
It can. It may not be worth it though, because, well, Supernode 1 is still a very good location. The antenna part of it is worthwhile. However, the fiber that goes from the rooftop to downstairs is fairly expensive. We also don't have, there's only one provider there that we possibly could, I mean, there's more than one, but there's only one that's like really friendly to us. So connecting at Supernode 1 at a really high speed isn't going to do much for us, because the rooftop also needs an upgrade. It's limited to 1 gigabit. So doing a lot of work at Supernode 1 for this kind of stuff isn't going to change much. We would actually be better off, I think, for a couple of reasons, moving the existing connection from Supernode 1 over to Supernode 10, the new Google building connection, and then using the existing high-speed antenna and reversing the flow of traffic back to Grand Street, right? So we could even do that and then search for a refresh at Supernode 1, but at the meantime, the building isn't that friendly to us. So getting a lot of fiber infrastructure there is kind of a losing battle. Yeah. Does that make sense, Jolly?
I think you could talk to DKIX.
We are on DKIX.
Yeah, but you could talk to them about upping your...
We can, but again, it wouldn't do much there. It'd be much better to do that at Supernode 10. Okay. Supernode 1, I think we can talk about the architecture, but I think it'd be much more worthwhile getting a 10 gig from Supernode 1 over to Supernode 10, and then landing the Supernode 1 connection that was originally there over on Supernode 10. Because we have a lot more capability and space and power at Supernode 10, and it's not going to be, I don't know, there's some questions there, right? Okay. I have talked to DKIX, and if anyone from DKIX is listening, I would love to have more bandwidth with you guys. But they offered us a small upgrade. I would love to go a bit more than that. So, but the way that DKIX is actually at Supernode 1, they're with a third party, and it will be quite expensive for them to do that, right? And on top of our overly priced fiber to the 6th floor, they would also pay an overly priced cost, and then another so it would be more expensive than just building a new site, right? Yeah.
Perhaps this is now into the out of scope territory as
Sure.
we veered into. Would it make, in terms of saving overall cost, would it make sense exploring even removing the downstairs, the fiber that goes to the 6th floor, and removing the rack space, and possibly doing a rooftop router?
Yes, I have thought about that as well. There's another option that I would like to explore with them when we're ready, which is they have a new 2-post rack next to all the 4-post racks, and some people are hosting power supplies on that rack. And it would be interesting if we could get a power supply there and get new DC cable to the rooftop, and then do just a rooftop router, right? So I agree with you completely. That is, I think, something we can do after we have enough stability at other locations, and we should also prepare ourselves to reverse the flow of traffic. For when we do all of that, we need to kind of have a nice transition. But yeah, I agree with you. Yep, for sure. Okay, all right. So. Yeah. So thanks for listening. Sorry if it was quite technical. I hope it was interesting. And let's see, what would we like to do next? Breakout rooms or something?
You mentioned board.
Oh, board elections. Yeah. So We have, yes, we have the board elections open right now. I mean, or the board elections are ongoing. The nominating committee and getting candidates lasted the last couple of weeks. This last week is registration. This previous week, that is, was registration, registering to vote as a member, right? Which is sort of required by the bylaws, more or less. And starting from today until next week, we're going to have voting. It's going to be a week-long voting. You can vote early. You can vote anytime during that period. It will end on next Tuesday at midnight. And so the official election is next Tuesday daytime, right? Which is a certain number of days after we announce the election, right? To try and make it all kosher and everything. But there's no reason you can't vote early or anytime because nothing's changing in between, right? So if you registered to vote, today is the last day to register to vote. Please register. And what we will be doing is there will be an automatic email that goes to you for the election. You click on the link, you fill out the details, you fill out which ones you want, who you want to be in what order, and then it'll be tallied by a system next Tuesday. Yeah.
You want to pull up the?
Leiden, yep.
You want to pull up the link there?
Yeah, I
It's in
don't know
general.
where it is. Boom, Slack. Let's see here. General.
Just scroll up in general, that's there.
Yep. Yep. So this is the voter registration. If anyone would like to register and you haven't done so yet, you can do so here. Additionally, at this meeting, if there's anyone who can't vote electronically and you want to vote on paper, please come let us know and we'll help you do so.
Zach, where can people find that link?
This is on Slack in the general channel. So
I received an email with something like that, and like.
yeah, there's in the newsletter as well. Yeah.
Yeah, I hit like the tab, but like it didn't send me anything in regards to. I received an email in regards to registering to vote, and I filled out the form, but there was I didn't see any follow up in regards to voting for.
Yeah.
X, Y, or.
Yep. There's no follow up yet. Today is the last day to register. After today, you'll get a follow up.
Aha.
Everyone will get the email at the same time about voting. For registered voters, we'll get an email that allows them to vote. Yeah.
Well, I wasn't quite sure if it was accepted or not. I filled it out and sent it off, and then I just was like, well, what happens?
Cool, no problem. Thanks for doing that. I think, Brian, do you remember how many people we have? Did you look recently? It's over 100 now, or?
It's around 100.
Around 100, yeah. I think there's a question in the back, if you don't mind passing the mic back.
Yeah, I'm just looking at the registration form,
Yeah.
and I am a volunteer that is not on the mesh.
Okay.
What should I put for I can put my street address in, but there's no node at that location, and it's not even a potential, actually.
Yeah, that's fine. Just put in your street address of where you live, and the reason is that according to these requirements here, you have to be in a potential location on the mesh. It doesn't mean that you need to be on the mesh. So if you're a volunteer who's properly volunteering with the mesh and you wish you had a node and you're in New York City, then fill in your address and you're completely fine to be a voting member.
Do I also have to go out and fill out the potential node form right now as well, so that technically I meet?
No, that's fine.
Okay.
I will point out that I've told you many times to fill out the join form,
There you go.
even if you have no intention of joining Mesh.
Yes. It's a good thing to do,
Yes.
to register your interest. Yeah. So, yep. Yep. Yes, sir.
Are you guys exploring like e-democracy or? Thank you. Are you guys exploring e-democracy and or like pass the poll, like the New York City election had like the whole pass the poll thing in regards to like different formats of democratic elections? Are you guys exploring that as like a territory to explore, or is this a functional election to satisfy the bylaws?
Yeah, I don't know about those things, so I can't speak to them. I'm sorry, but we're just doing a simple election. We're going to do a single transferable vote, ranked choice simple transferable vote, and it's because we don't really have a giant pile of people to elect, and it's kind of a functional election, as you mentioned. It doesn't mean that it's like a worthless election, but
Didn't say that at all.
No, I didn't say you did. But what I'm saying is, it's not like it's a doing it for no reason other than to do it, right? But the point is that we don't really need to add any. I don't think we need to add anything else. Like, it can be improved, I'm sure, but it's basically just a very straightforward thing we have to do.
I mean, in terms of, like, pass the poll may work in regards to taking some of the workload off, as Brian was saying, like that.
I don't know what that is. Can you maybe briefly
like, all
explain
right,
it?
well, like, I mean, pass the poll is like if the first person that you get to select more than one nominee in regards in a certain descending order. Like,
Yeah, we're doing
person,
that.
yeah. Oh, you are doing that.
Yeah, we're doing. It's called single transferable.
Oh, yeah. All right, yeah.
Yep,
This
that's what we're
is
doing.
the same thing that we're talking about, right?
Yep,
All
we're
right,
doing
cool.
that.
But then also in that descending order, being able to fill in all the all the necessary roles that like seem a bit top heavy. Like, and in terms of some people do it like 10% doing like 100% of the work or whatever.
Yeah, I mean, the election is not necessarily to choose who does what or anything. It's just members of the board.
Oh,
Yeah,
okay.
yeah.
It's not a division of labor type thing.
I don't know what that means.
I think the question can be answered like this election is being done to, as said, satisfy the bylaws, and because we have to do it as a nonprofit.
Yeah.
The overall NYC Mesh board, as Brian has said, is the kind of final decision on many projects, but I think most projects in the mesh happen without much input from the board because it's not needed for most day-to-day operations. And I don't think this election isn't changing day-to-day operations in any foreseeable factor for the overall mesh.
Exactly. The board, people's opinion will vary, which is completely fine. The board doesn't really do much. It's more of like the keeper of the funds, the insurer that things are, legal, ethical, and for the benefit of the community, right? It's not really like these people aren't the ones who are doing stuff. Some of them do things, but doing things like if they're a volunteer and they commit a lot of time is a different axis than their board responsibilities. Yeah.
I think like 2 months ago there was a very good explanation of what the board is.
Yeah, we've had a couple explanations of what the board is, which is what High Tech was just saying. I'm sure we streamed one of them. If not, there's slides in Slack from our previous meeting that go through that. Brian's done one a couple months ago. I did one. Brian just did another one. So, and there's like definitely a lot of discussion in Slack, as Brian mentioned. There's a lot of history in there that you can read through. So yeah, I definitely agree that this is like, the board doesn't do much. They do something important, but not very much, right? And so it's kind of, and maybe that'll increase in the future, but this election doesn't have it doesn't assign who does what role, right? It's just board members generally.
Yeah, I think it's on the YouTube, right? I think 2 months ago on the YouTube it was recorded really well. With
Yeah,
the
we did
definition of
one that was recorded, and then there was one where Jolly couldn't make it, and so we didn't record that one. The slides are just posted. So yeah, there's a couple variants. Okay. Cool. Anything else, Brian? What else is on our agenda? Yeah, is there anyone who hasn't signed up for registered to vote yet? Daniel didn't. You're running for the board. Okay, interesting. I see negligence already. I also haven't, to be fair. So yeah. Yes. Today's the last day. If you haven't and you would like to, see one of us after, and we'll help you. I don't think anyone here needs to vote by paper, but if you really want to, if you need to, then come let us know, and we'll help you do that as well. If you can vote electronically, that's preferred because it's more fair and safe. So, yeah. Okay. All right. I think, what should we do now, Brian? Breakout? Yeah. Okay. All right. Well, thank you for joining us, to the YouTube people. And we'll just have random discussions now. So thank you. Yeah.